All right, so we'll go ahead and get started. We'll just jump right into it and talk about data wrangling with dplyr. But I got to do a little bit of, I guess, give a grumpy professor um, chat here. Okay, and I just want to kind of reiterate that, please read through your entire homework output before you submit it. Okay, make sure that all the kind of requested output is visible. I've received a couple regrade requests for submissions that look something like this, where it just says stuff like can't open the file, and this is probably a silly mistake where they they didn't put this text file in their working directory or something like that. And unfortunately, this is not going to earn any points in the regrade. So please just make sure you read through your output and that the output looks correct before you submit it. Okay. And it's not fun losing points for a silly mistake, and I get that. And a silly mistake like this might cost a student a percentage point or two in their final course grade, and and that's never fun. But I think this is a relatively small price to pay, in my opinion, of course, and it'll be worth the consequence if it kind of motivates someone to pay a little bit more attention to detail, kind of double check their own work, especially before making some kind of submission. When you apply for jobs in the future, they're gonna, or even internships, you might see a description. It might say something like, we need someone detail oriented. And it's always kind of like, well, what does that even mean, to be detail oriented? And a lot of times what that means is that, silly mistakes, little mistakes can actually have large consequences. And they want somebody who is going to be double checking or triple checking their own work before kind of submitting it for whatever, right? And so, you can imagine the consequences of, if you're applying to a graduate school and you submit the wrong version of a personal statement on a school application, right? Because you might use the same personal statement for multiple schools, but it might say like, I believe I'm a good fit for Columbia's graduate program, but you accidentally send that to Stanford or something like that. Okay, that's an embarrassing mistake and will probably cost you, an otherwise qualified candidate, something like that could cost them their admission or something, right? Another embarrassing thing would be CCing someone, the wrong person, on an email that contains confidential information or something like that. That's embarrassing and possibly could have legal consequences depending on what kind of information was included, right? Other kinds of small mistakes that have significant impacts are things like having the wrong digit of a bank account number, an extra zero, and a dosage of medication. These are small mistakes that have major consequences. And so, I want all of you, I want my students to truly achieve, your dreams and your potential. And I don't want silly mistakes like this to kind of hold you back from that. So, anyway, all to say, it's good to double check your own kind of works, right? And after I say that, I'm afraid that like now my slides are going to be full of typos and mistakes and errors. So while I preach this, I also, please don't crush me. And and if you do catch typos and stuff, I always welcome your feedback to further improve my notes and slides. All right, so let's go ahead and jump into and talk about dplyr. And so dplyr is part of the tidyverse. You can load it up by calling library dplyr, or you can also call library tidyverse. And of course, you have to install this. And so you can always do install.packages tidyverse or dplyr individually. And this is straight from the dplyr help pages, the dplyr vignette. And that is, when you work with data, a lot of times you got to kind of think about what it is that you want to do. You got to kind of describe those tasks and operations into some form that a computer can understand, and you have to execute it. And what dplyr does is it kind of makes these steps, in my opinion, fast and easy. And what dplyr also believes they've succeeded in accomplishing. And so dplyr provides a set of verbs, okay, kind of constrains what you can do. And it forces you to kind of think of like, okay, what can I achieve in this moment, right? And so these verbs will kind of perform common tasks, and then from there, you can do quite a bit. And so we're going to take a look at some of these primary verbs that come with dplyr, and they are select, which is going to be used to select variables, and filter is going to be filtering the observations or the cases, okay? So select is for columns and variables, filters for the rows. Mutate is going to add new variables to your existing ones. Arrange is going to change the order of the rows. And then summarize is going to take kind of the cases, multiple values, and summarizes them down to a single value, right? So things like the mean is, find the mean is is a summary operation. It takes multiple values and shrinks it down to a single one. Okay. And all of these summary things, or even just a lot of these things, will combine naturally with a function called group by, which allows you to kind of perform these operations by group. And we'll take a look at a few operations or examples of that. Okay. There's also a very good cheat sheet that's you know, this is the official cheat sheet produced by RStudio. Okay. And it's pretty good. All right, so before we get into the examples, let me go ahead and give you your first quiz answer for today. Oh, happy Monday, by the way. It's already 4th week, and I know some of you guys are already facing midterms, and so I just want to wish you all good luck with that. But first quiz answer for today is E. E as in elephant. E as in elephant is our first quiz answer. All right, so our first, the first thing, all of our examples are going to be working with this Star Wars data set. And so if you're familiar with Star Wars, great. And if you're not, it doesn't matter. It's just we're going to be applying these operations here. Okay. And so this Star Wars data set is 87 by 14. There's 87 rows. It contains information about, I guess, 87 different characters that exist in the Star Wars universe. And it has 14 columns, and those columns are things like the character's name, the character's height, mass, hair color, skin color, eye color, birth year, sex, gender, their home world, their species, and along with other things, a list of films that they appear in, a list of vehicles that they've driven, and a list of starships that they've piloted. And this has information from the first 7 Star Wars movies. So that would be original trilogy, prequel trilogy, and The Force Awakens, not including, but it doesn't have movies 8 and 9 or the other, what was it? The Star Wars stories, Solo and Rogue One. Okay, but anyway, or the TV series. Okay, which or Star Wars Lego or the, you know, extended universe thing. So just things that from this first 7 movies. Okay, so anyway, select is used to select columns. Okay, and so the way select works is it says you give it the table or the tibble name, which is Star Wars here, and then you provide the names of the columns that you want to select. So we want to select the column's name, homeworld, species, and films. And notice I don't put quotes around these things. You can put quotes if there's a space in the name, but in general, you know, it's generally recommended that column titles don't have spaces in them, and you don't have to put quotes around them. And it's going to understand that these are column names. So here it's selected the 4 columns: name, homeworld, species, and film. And we see Luke Skywalker comes from Tatooine, is a human, and I guess was in 5 films, okay? Because, well, anyway. So so the first argument for all of these dplyr verbs is going to be the table upon which to perform the operation. However, we encourage the use of the pipe, okay? the pipe takes the result of what's in front of the pipe and inserts it as the first argument in the function that comes after the pipe. And so if we have x piped into fy, that's equivalent to calling the function f of x comma y, right? So here I've got Star Wars piped into select name homeworld species film, and that's exactly equal to saying Star Wars, select Star Wars, okay, because this first thing gets piped in right as the first argument, and then the other things, okay? And so the result here is going to be exactly the same. Table with 87 rows and 4 columns, where we selected the columns, name, homeworld, species, and film. All right, the shortcut to insert the pipe in your code as you're working is Control or Command Shift M if you're working on a Mac, and that way you don't have to keep hitting % greater than % to insert a pipe. So it's very handy. Okay.
Professor,
so,
I have a question.
I'm going to just show you a few examples of these things. You can use a negative sign to deselect columns. So here I can say I don't want the name, eye color, or birth year columns, and we get these 11 columns here. Okay, and again, notice I've piped the result of selecting that into the function head, where it says I just want the first 3 rows. There's a question in voice chat about Star Wars. Oh, what's the difference between using the pipe versus using select? Well, so you don't have to use the pipe, okay? But using the pipe is, I believe, helpful in that rather than having to specify the result as the first argument, okay, you can kind of pipe it. And so later on, we're going to be performing operations, kind of like a sequence of operations. Do this, then do this, then do this, then do this. And I think it's going to, it's actually, I think, easier to read and understand when we use the pipe. And so I'm just gonna have to say, just stick with it for now, and we'll see kind of these commands build up using pipes. And they're kind of written in a form that they're kind of linear and I think understandable. Okay, another option for selecting columns is you can say, you can use the colon notation, and that's going to select a range of columns. So you can say, I want to select the columns name through eye color. And so let me just go back a few slides. This is the original tibble with 14 columns. And so here I'm saying, I want to select the columns name through eye color. Okay, and so it's going to get name, height, mass, hair color, skin color, eye color, and it's not going to get the ones that come after: birth year, sex, gender, etc. And so here I said, select name through eye color and just give me the first 3, and that's what we get. There are a series of special functions that we can use with select, okay? And this comes with kind of the tidyverse. We have the select helpers. And so these are things like, you can say, I want to select columns that contain a certain character string, columns that start with a certain character string or end with a certain character string that matches a regular expression. We haven't really covered regular expressions yet, but that will come in our next lecture on Wednesday. We'll look at more regular expressions. You can say select all the columns or a range, a numeric range. If you have columns that are named something like x1, x2, x3, x4, you can look up the help on numeric range or one of where the names are stored in a vector. So here's just kind of an example. You can say, I want to select from Star Wars, select the column name and all columns that end with color, okay? Columns that ends with color. And so we get the name column, hair color, skin color, and eye color. Here it says select the column name and matches this regular expression. This regular expression, and again, we haven't covered regular expressions yet. This means the column ends with an S, okay? Now this is, I could have just done ends with S here and that would have worked, but this regular expression is also another way of saying ends with an S, okay? And I just wanted to keep a simple regular expression that that works here, okay? And so here it gives me all the columns that end with S: mass, species, films, vehicles, and starships. You can also produce a variable that contains vector, like a vector of names here. So here I've got vars, and I want to select the columns names, mass, and height. And you can do Star Wars select all of vars. Okay, and this will select the columns name, mass, and height. Okay, so if you have a different function or operation that's going to create vectors of column names, it can be used this way. Okay, so that's selecting columns. As far as filtering rows go, we use the filter operator. Okay, and so the filter operator, what it requires is it requires a logical vector. A logical vector that's the same length as the number of rows in the original tibble. And so our original tibble has 87 rows, so it requires a logical vector that's going to have 87 true-false values. And so in our case, we're going to say from Star Wars, filter it so where name is equal R2D2. Okay, and so here we're going to get a logical vector of true-false values, and it's going to be false everywhere except where the name is equal to R2D2, and it returns that one row. Okay, but you could provide any kind of logical vector that is of length 87, and it would work, right? So you could do like 1:87 mod 3 equals 0, and then it'll select every third row or something like that. Okay, so any kind of logical vector with the same length as the number of rows will work for filter. Here's a few more examples. Okay, so I could say select where the species is a value that's in this vector, human or droid. Okay, and so that's going to select all the ones where the species is equal to human or droid. And so anytime you use a comma, that's equivalent to using the and sign. Okay, and height is less than 175. Okay, so it's going to select every one where the height is less than 175. And so we have these people, androids. Okay. Filter can be used paired with regular expressions. Okay, oh, we have a question. It says, going back to slide 19, it says, does this mean that if we have a null in our data set, we can't use filter to filter rows? So I think you mean NA. So if you have an NA, you know, if you do name equals or hair color equals, say, brown, okay, then it's obviously not going to match the NA, yeah. So, but you can do it, and it's not going to cause issues. It just won't match that, right? You can also use the is.na operator. Is.na will return trues and falses, and you can use that. Okay, so there's a few ways to handle missing values. So is.na will handle missing values, but if you say, you know, is it equal to something, then the ones with missing values won't match that. Okay, so again, we haven't covered regular expressions, but string detect is an operator that takes a regular expression and it will return true or false if the regular expression here matches something in the character string. So this regular expression means return true, match true. The match is true if the string begins with the letter F, and it's going to be false for when the string doesn't match doesn't begin with the letter F. Okay, so here we're going to say filter it where the name returns true with this regular expression. So it's going to give me these characters where the name starts with a capital F. So we have Finn, and I don't know who this is, okay, but a human from Coruscant. Does anybody know who this character could be? I have no idea. Okay. I mean, I like Star Wars, but I don't know anybody other than like the main characters from the series. Okay. So this is an example of piping the results into each other. And so here we're going to say, we're going to use the OR operator, okay, on filter. So we're going to say hair color is equal to none. So hair is equal to none, or eye color is equal to black, okay? And then from there, we're going to take the results. So notice back when I was filtering all of the results, it kept all of the columns, all 14 columns here, anytime I've done these filters. But we're going to kind of combine the filter and the select. So we're going to take the filter, and I'm going to pipe the result. So the result of filter is going to be a tibble with 14 columns, but we're going to pipe that into the select operation where I'm selecting just 5 of the columns. So here, the result is going to be 38 rows, and these are all characters that don't have hair. Darth Vader has none, IG-88 has none, and something like that. Greedo is unknown of what hair color it is, but qualifies to be part of our table because eye color is black, right? And I don't know who this is. Nien Num, whatever, okay, has black hair, okay? And this actually is true for yes, okay. And so this is the resulting table here. So you can use OR using the single OR here. The results can be sorted using a range, okay? So here I've got select the name, the birth year, the height, and the mass. And birth years in the Star Wars universe is based on the Battle of Yavin. That's their 0 point. So people who were born, characters born before Battle of Yavin is, has a birth year like 896. And then, people born after that have, some other thing. Okay. So Yoda is like one of the oldest characters. Birth year is 896. I guess this is Jabba the Hutt. Birth year 600. Chewbacca, conveniently born exactly 200 years before the Battle of Yavin, okay? And we're going to, and so we can say arrange by birth year descending, okay? And so that's what we have here. And then if there's a tie for birth year, then arrange by mass ascending, okay? And so here we've got, I have no idea who these people are, but Qui-Gon Jinn was the main character in the first prequel. So we got 92, 92, and then 82, 89 ascending here, okay? And then it appears that missing values get arranged after the values. And there's probably an argument as far as where missing values should be placed in the arrange, okay? So here, Palpatine, 82, 82 before Battle of Yavin, and the mass, Palpatine's mass 75, and here missing, okay, comes after. You can select rows just based on their indexed position using slice, okay? So head will just generally return like the first 5 rows or the first 10 rows or something like that. But what if you wanted like the rows 5 through 10 or something like that, okay? You can do that by using slice, okay? So you can say, I want to slice that, and then it will renumber them so that the first row in the result will start at a 1, but this is going to be the 5th row in the original table. So the 5th row through the 10th row in the original table will become rows 1 through 6. So that can be achieved using slice. Slice only works for rows. Slice only works for rows. Okay, if you want to select columns, you can use the colon operator. Okay, you can use the colon operator like this. And this is kind of like slicing, but you need to provide it. You need to know the kind of column names there. Okay, so here we've got slice for selecting the rows. Other handy features of slice will be you can slice a sample. And so if you just want to randomly select rows from your table, you can say slice sample, and this will give you kind of like 5 randomly selected rows. And this could be useful because perhaps your table is arranged in chronological order, and you just kind of want to get an overview of different regions of the table without having to say slice the first few rows and slice the middle, this row and this that. You can just say give me like 30 randomly selected rows, and then you can kind of get a quick peek at stuff spread throughout the table rather than just things at the beginning or the tail. There's also slice min and slice max, and you can, in this case, you specify a column and it will return the largest or the smallest values in that column. So this is kind of like using an arrange and then a head operation, or a range and a tail operation, or something like that. But the slice min, slice max just kind of simplifies that into a single operation. So here we're going to say, take the entire table. So that's all 14 columns, but just slice where we get the characters with the largest mass. Okay, and so we get the largest mass here. So that's selecting rows and stuff. We can also create new variables. New variables can be created with mutate. Okay, and so when you do use mutate to create a new variable, it's going to create place the new variable all the way at the end of the table. So a lot of times you're going to have to pair this with a select function. So for example, I can say take the Star Wars table and add a new column for height in inches. Okay, so 172 centimeters. That's great for everybody not from the U.S., but for people in the U.S., have a hard time understanding centimeters. And so you can say, well, I want to take the height and divide by 254, and that's going to give us the height in inches. But this new column is going to get placed all the way at the end. Okay. Excuse me. And what Tibbles do is that variables that don't fit, just get put on this line with the ... with 3 more variables, this, and this, right? And so we're going to have to kind of pair it with mutate select, and we're going to say create this new column height in inches, where we take height divided by 254, and then select the name, the height, and the height in inches. Okay, so now we have Luke Skywalker, 172 centimeters, and height inches 67.7. Yeah, head 1 just says return the first row. Return the first row. Okay. One thing about mutate is that whatever it is producing here, it needs to have the same number of values as rows in the table, because it's going to be adding an entire column, right? So if my table has 87 rows in it, whatever new column I have has to also have 87 values in it. Okay. And so if you use something like mean, give me the mean of mass, that's not going to work, because what mass will do is it's going to take 87 values and it's going to find the mean, and there's only one value for the mean. Okay. But it can do something like the cumulative mean. Cumulative mean will produce a vector of length 87, and that will work. So cumulative mean will say, okay, we started off with 77. The mean so far is 77. The next value I see is 75. So the mean of 77 and 75 is 76. The next value is 32. So the mean of 77, 75, 32 is 61.3. So cumulative mean is going to be very sensitive to the order or the arrangement of values that it sees. Okay, so so if there is, cumulative mean is probably meaningless in a data set that's arranged like this. Okay, but it's going to be meaningful if you have, where the order, like time series data, where the order of data has meaning and significance, then the cumulative mean will be more meaningful here. So these are examples that of functions that can be useful for mutate. We have pmin and pmax. These are the element-wise min and max, and I'll show you an example of what exactly element-wise min and max is. We have the cumulative min, cumulative max, cumulative sum, and cumulative product between, which is going to be a yes or no, or true false, I should say. Cumulative mean, which we saw an example of. We also have lead and lag, and n-tile, which is going to kind of bin the vector into n different buckets. So here we're going to say take Star Wars, then select the columns name, mass, and birth year, and then add, mutate, or calculate new columns. The new columns are going to be the cumulative min of the mass, the ratio of mass to the mean mass, the mass year pmin, the element-wise pmin, and lag 2. So let me just kind of show you what these things are. So the cumulative min is just the cumulative min of the mass. So it's going to just say what's the smallest value, the minimum value we've seen so far. So the first value is 77. So that's the smallest value we've seen so far. The next value is 75. That's even smaller than 77. So the minimum so far is 75. The next value is 32 for the mass. That's the smallest value we've seen, okay? The next value is 136. And so the smallest value we've seen so far is 32. Next value, 49. Smallest value we've seen is 32. And so on and so forth. We haven't seen anything smaller than 32. The ratio, it calculates here, it's going to calculate the mean of everyone. So it's going to take the mean after removing missing values. It's going to calculate the mean mass for all 87 characters. And here, Luke Skywalker's mass is 77, and that's about 80%. I think the mean of everyone is something around 97 kilos or something. And so Luke Skywalker is, 77 divided by 97 is 0.979 or something like that. Okay, so we get these values here. The p-min, I'm taking these two columns, mass and birth year, and this has no semantic meaning, but it's just an example of what it's doing with the numbers. It's going to take these two columns, and element wise, it's going to do comparisons between this column, between the mass column and the birth year column, and just tell you what the minimum value is. So between 77 and 19, 19 is the smaller number. Between 75 and 112, 75 is the smaller number. Between 32 and 33, 32 is the smaller number. Okay, so it's just kind of going through these two columns and comparing them and returning the min or the max. And you can provide multiple columns, and it's going to kind of element-wise compare the values down the column. Okay, and then lag 2, here we're saying lag this column, mass year p-min, and lag it by 2, and it's just going to copy the values in this p-min column and offset them by 2. Okay, so 1975, 32 starts down here, 2 rows later, 1975 and 32. Okay, and again, these have no semantic meaning as far as the characters for Star Wars go, but an operation like lag2 and p-min can be useful for something like time series data, or if you have like stock information where you kind of want to do like, what's the comparison today versus 1 month ago or something like that. You can use a lag, or you can use kind of the min max for the day. All right, now we can get into summary functions. Actually, before I get in there, I've only given you one quiz answer so far, right? So let me give you your next quiz answer. Second quiz answer for today is C. C as in cat. C as in cat is the second quiz answer. Okay, so the author of dplyr is Hadley Wickham, and he is from New Zealand, and so they spell the word summarize with an S, okay? He later added the function summarize with a Z for Americans who spell it this way, and it has the same functionality, but my training and kind of the original function is using the S, so I'm going to continue using the S here, but yeah, I think both of these functions, I think summarize with a Z is an alias for summarize with an S. Okay, so anyway, what the summarize does is it will allow you to create summary values. Okay, and so you use a summary function, a function that takes multiple values and reduces it down to 1. So things like finding the mean, finding the variance, finding the min of a set of numbers or the max of a set of numbers. These are all summary functions that take multiple values and reduce it to 1 value. Okay, and so here I'm going to say Star Wars, just select the height and the mass, and then produce a summary table, and we say, give me the average height, which will be the mean of the height, average variance of the height, and we take the variance of the height. And notice I was saying ignore all NAs, remove the NAs. Average mass, minimum height, maximum mass, and then the count, which is just going to be how many values it is are being summarized here. Okay, and so I get a resulting table with just 1 row and 6 columns. Okay, is there a parameter for na.rm for select? There is not. Okay, select selects columns. Okay, so as far as columns go, there's no na.rm to go. Okay. As far as filter goes, when you use filter, by default, it's not going to match missing values. But if you want to explicitly include or exclude missing values, you can use is.na. Is.na is going to return true and false values for rows that have missing values, okay? But as far as select goes, those are for selecting columns, so it doesn't really make sense for a column to kind of be NA itself. Okay, so anyway, this is what we have. Now you might look at this and you say, well, this is kind of silly. I could have just done mean of height. I could have just done variance of height, mean of mass, and I would have gotten these values, okay? And it wouldn't be arranged in this nice little table, but I don't really care, okay? And that's a perfectly valid complaint, because right now summarize all by itself doesn't do a whole lot. But the power of summarize is realized when you pair it with the group by function, okay? And so let me show you what the group by function does. So group by takes the table and it applies grouping information. Now, group by all by itself doesn't look like it does anything, okay? The only thing it really does that is noticeable is that it's gonna add this one line that says groups, species here, okay? So here I say Star Wars group by species, and then it just adds this one line that says I've created 38 species groups, right? So we've got humans and droids and I don't know, there's other species, there's Wookiees and stuff, okay? And it's created 38 groups based on this species, okay? And then from there we said, select name, height, mass, species. So group by itself doesn't seem to do much, but group by and summarize paired together is very powerful, okay? And group by and summarize is similar to dplyr that you might have learned in Stats 20. And I know some of you in Stats 20 have already covered dplyr, and I apologize that today's lecture is a bit of a review for you, but for everyone who didn't cover dplyr, the group by and the summarize is similar to dplyr, but I think the vocabulary here is a lot easier to work with here, okay? So let me show you what this will do, all right? So here I'm doing Star Wars group by species, and then select the name, height, mass, and species, and then create a summarize table, okay? And so as far as summarizing it goes, it's gonna apply these summary functions by species, okay? And so it's gonna find the mean height, the standard deviation of height, the mean of the mass, standard deviation of the mass, and the count by the species. Okay, so I don't know what these species are, but the Alina species, apparently there was one character of the Alina species, one character of the Basilisk species. We have 6 characters of droids, okay? So when there's only one, there's no standard deviation to be calculated, okay? And so I end up getting 38 rows. I have 38 rows because it says it has identified 38 species here. Okay, now what I can say is, well, you know what? This isn't quite what I wanted because I don't really care about these species where there's only one character. So what I'm going to do is so notice I'm just kind of building up on this. I have group by, select, summarize. So we're going to say group by, select, summarize. And then after you summarize that, take the result of the summary table and filter it so that count is greater than 1. And then I want it arranged by count descending. And then just give me kind of the first 6 rows here. And so here we have humans. There's 35 characters and the mean height is 177 and the standard deviation is 12.5. Droids, the mean height is 131. Standard deviation is this. Then there's 4 characters that have no species, and this says Gungans. Okay, Gungans from the planet Naboo. There were 3 species, I guess, named characters of that species here. Okay, so this has summarized a lot of the data, and it is doing it by the species group that we have specified here. Okay, and so this is a very powerful function where it's going to kind of group your data by whatever groups you've created here, and then it's going to apply the summary functions according to each group. All right. Is that all right here, as far as the grouping and the summarizing goes? Okay, so the name is not used here. Yeah, it is correct. So as far as select here, I didn't actually need to include the name here, because what it's going to do is basically this resulting thing, the resulting table for summarize is only going to have the columns that I've defined. It's only going to have these columns that I've defined, mean, height, and this and that. And then one more column, which is going to be the grouping columns, okay, which will be the species. So yeah, this was not being used. Okay, I guess I could have used it as far as for summarize if I said like max name. I don't know if max name would have been working, which would have been kind of like the alphabetically first or last something here. Okay. Group by can also be paired not only with summarize, but something like mutate. Okay. So, so here I'm going to say, all right, take Star Wars and just filter it to species that are either humans and droids, or the species is missing. Okay. And then from there, we're going to select the name, the species, and the height. We're going to group by the species, okay? And notice I'm not using a summarize function. I'm using a mutate. Mutate says create a new column. Create a new column, and this is going to be z-score for the height. We're going to take the height z-score. And so z-score is, distance from the mean in terms of standard deviations. So it's going to be the height minus the mean divided by the standard deviation. But the mean here, the mean is a summary function, and so those means are going to be calculated by group. Okay, so the key difference is, notice Luke Skywalker has a height of 172, and C-3PO is shorter than Luke Skywalker with a height of 167. But because the mean is calculated by group, and the standard deviation is calculated by group, Luke Skywalker ends up having a negative z-score because the group mean of humans is taller than Luke Skywalker. Whereas C-3PO, even though he's shorter, is taller than the average droid height. And so he ends up having a positive z-score. Okay, so as far as the z-scores, they are calculated relative to their group. So Luke Skywalker will end up with a negative z-score, and C-3PO will end up with a positive z-score compared to their group, because these are calculated relative to this grouping, okay? Relative to their group species, their species group. So the mean is calculated by group, okay? If I take this exact same command, and I'm going to just comment out this one line, group by, okay? I comment it out, and now the mean and standard deviation is calculated for the entire table here, okay? So after I've done the filter, it's going to be calculated for that entire table. And so C-3PO back here had a positive z-score with a height of 167, but now he is below average, and so his z-score ends up being negative, and Luke Skywalker is now above average, and he ends up having a positive z-score, okay? Question, does the order of the first three arguments matter? Which first three arguments are you talking about?
So it's
select?
filter, select, and
I'm so
yes.
sorry?
So it's gonna be filter, select, and summarize. So does it matter if I like change the order they appear in this
So
argument?
I guess so you can probably alter. So filter selects the rows, or filters the rows, and select filters the columns. So probably the order of filter and, well, actually it could make a difference in that you could filter, like I could filter based on, say, species and birth year or something like that. And then when I select, I don't have to include birth year. Okay, but if I selected, if I did my select operation first and I did not include birth year as one of the variables I selected, then I would not be able to filter based on birth year, because birth year is no longer a column that exists. Okay, so you kind of just have to think like, does it kind of matter? As far as the grouping, I would say the grouping should yeah, so the order does play a role. You know, in this specific example, I could probably apply the group by earlier on and I would also be okay. But, you know, depending, you know, where you position it versus the filter, basically whatever variables you use, right? So here I'm using the height variable. The height needs to be a variable that I've selected here, okay? I could move the select to after this, and then I could use variables that I didn't necessarily select later or something. So the arrangement of the orders of the commands or the verbs do matter, because we're saying begin with Star Wars, then filter it, then select, then mutate, and things like that.
Oh, thank you. I got it.
Okay. All right. So, you know, make sure you understand the difference between this, where I've applied the group by and I did not apply the group by. Okay. Here's I got to work a little bit faster here. Here's just a simple toy data set. And I'm going to apply multiple group by operations here. Or actually, I'm going to create, I guess, a multi-level group by, right? So I've got Afghanistan 99 female, Afghanistan 99 male, Afghanistan 2000, year 2000 female, Afghanistan year 2000 male, and so on and so forth with Brazil and China, okay? And, you know, just for simplicity, this is like cases of a mysterious disease where we had 1, 2, or 3, just for simplicity here. And what I'm going to do is I'm going to group by country and year, group by country and year. And so that's going to create 6 different groups. Okay, we're going to have Afghanistan 99, Afghanistan 2000, Brazil in 1999, Brazil in the year 2000, China 99, and China in the year 2000, because we're grouping by country and year. And the summary is we're going to sum the number of cases. So it's going to take the number of cases and it adds the 1s and gives me a 2, adds the 2s and gives me 4, and adds the 3s and gives me 6. Okay. Because I've done a multi-level grouping, I have group by country and group by year. Within this result, the country groups still exist. Okay, so we have a group for Afghanistan, a group for Brazil, and a group for China. It's kind of multi-level. And so I can take this result, summary 1, and I can further summarize and say cases, summarize with the sum of the cases here. And now the result is going to be Afghanistan with a total number of 4 cases, Brazil with a total number of 8 cases, and China with a total number of 12 cases. And the tibble, if I summarize this even further, it's going to, there's no more groups here, and so it's going to give me one final result of a 24. Okay, I could do the same thing, but I've changed, and so here's a typo, but I could say group by year, then country. Year, then country, I will still have 6 groups, okay? I will still have 6 groups, but it's now 1999 Afghanistan, 99 Brazil, 99 China, year 2000 Afghanistan, year 2000 Brazil, year 2000 China. And there are now 2 groups, one year 1999 and year 2000. So if I take this summary table here and then apply another summarize to it, I'm going to get 1999 with a total of 12 cases and the year 2000 with a total of 12 cases. And then again, if I apply summarize on this, I'll get the result with a total of 24 overall. Okay, so you can create kind of multi-leveled groups, and the way it handles is going to be slightly different. Okay, so here's kind of the original, and we can create 6 groups by country then year, or we can also create it by year then country. Okay, and I'm going to just go through this very quickly. And this is 2 table verbs, and I think there's enough here to go off of. Okay, we're going to look at joins. Okay, joins allows you to take kind of 2 tables and merge them together, right? And if you're familiar with SQL, this is going to look exactly like SQL. And if you're not, I think these are simple enough to understand. Okay. There are different kinds of joins as well, and I'm not going to cover them in my slides, but you can read more about them at the official dplyr documentation. So I'm creating 2 toy tables, okay? I've got a people table with 4 rows, Adam, Betty, Carl, and Doug, and states California, California, New York, and Texas, okay? And then I have a states table, and it has the abbreviations California, CANYWA, and state names California, New York, and Washington. Okay. And so what I can do is I can join these two tables together. So I'm going to do a left join. The left join takes all the values in the left table, which in this case is people, and it's going to add the variables from the right table, okay, by matching values using a column that exists in both tables. So the column that exists in both tables is state for people, matches the abbreviation in the states table. So I'm going to say people left join with states and take the state column from the people table and match that to the abbreviation in the states table. Okay, and so we get name, state, CA corresponds, and it adds the columns from the other table, which will be California, California, New York, and it finds no match for TX, right? Because here there's no match for TX. So it just gives me an NA. So the left join keeps everything from the left table and returns matching information from the right table. Right join is just the opposite, okay? It keeps all the information in the right table and only gives you matching rows from the left table. So in the right table, we have an entry for Washington, but there's no person from Washington, so we get an NA here. And there's nothing for Texas, so that gets thrown out. The inner join is kind of like the intersection, and it's only going to return rows where both match, okay? Inner join, that has to exist in both, so as far as abbreviations, only California and New York exist in both tables. And then the full join is kind of like the union, where it's going to kind of give you all the values in the left that match the values in the right, and all the values on the right that match values on the left, and just fill in NAs for things that don't. Okay, so that's the full join. So that's kind of like the union. Okay, there are a few ways you can specify how to do the matching. Okay, what we've done is in this form where you have the left table and the right table to actually have different variable names. But a lot of times you'll have tables where you have names that actually match. And in that case, you don't even have to specify any kind of matching arguments. dplyr will automatically just say, oh, these column names appear in this table and the same columns appear in this table, and I'm going to try to match them accordingly. But you can, it gives you a few finer options for specifying which columns you want to use for matching here. Okay, let me give you your last quiz answer for today. Last quiz answer for today is A. A as an apple. A as an apple. All right, and that's it for today. And so we'll end there, and we will see you guys on Wednesday to talk about regular expressions. Have a and I'll also post homework 3.
Sorry, Professor, I got it.
Get started. Yeah.
Yeah.
Question.
Yeah, I got a question regarding homework 1.